Teardown of the Zonti's 150X engine. Everyone has been asking for an update. Let's see the quality of the materials used in this engine. The transmission box air intake has a filter element. As for the body parts, I already showed them in the previous video. For those who haven't seen it yet, you can go back and check the previous video. This engine comes with an external oil filter. The 150 engine I'm dismantling right now is quite rare to have an oil filter. One thing I must remind everyone: this filter can physically be installed backward, but doing so will damage the engine. So, you must pay close attention. This side faces upward. I just tried it on site. If you install it backward and put the filter cover on, the gap between the cover and the casing will be too large. You could force the screws tight. So you must double check the filter's direction. Look at this bearing. It uses TPI bearings from Taiwan. The transmission cover is made of aluminum alloy. Next, let's look at the drivetrain system. The clutch/variator is from FCC. It's a Taiwanese brand with a factory in Jinan. I'm sure everyone is familiar with FCC. Now, let's look at the belt. The belt is double-sided toothed. It's a high-quality Gates belt. The rear drive assembly is also from FCC. And the clutch bell has been skeletonized for weight reduction to achieve lightweight performance. The clutch shoes are quite wide, wider than the standard 150 cubic centimeters ones. All are made by FCC. Next, let's look at the variator weights. Let's weigh the variator rollers to make it easier for those looking to modify. The weight is 18.05 grams. Now let's look at the oil seals. The oil seals are from NOK Japan. That goes for the entire engine. As mentioned in the last video, Old Chow takes this bike very seriously. Besides the 150 cubic centimeters version, there's also a 175 cubic centimeters version. At the Milan show, I also saw a 125 cubic centimeters version, likely targeted at international markets. It uses the same engine block, just with a smaller displacement. I mentioned in the previous video that the sealant on the cylinder head cover was applied quite messily. Now that I've reached the cylinder head cover, let's see if the sealant overflowed into the interior. Let's look at the exterior first. The excess glue on the outside does look a bit ugly. Fortunately, there is no overflow on the inside. The sealant seems to be applied only to the outside of the gasket. This will be easy to fix during mass production, so I won't count it as a major flaw. The cylinder head cover also has oil passages. Notice these holes. Engine oil goes through the head passages to here, then into these 4 holes to spray oil onto. The camshaft and rocker arms. Once covered, you can imagine how it works. Okay, let's inspect the sealant on the cylinder head again. It's confirmed. A lot of sealant was used on the outside, but on the inside, there is basically no overflow. In my personal opinion, since there's already a gasket, the sealant might not even be necessary. On the cylinder head, there's a small cap, one on top, and another one below. What are these for? Looking at the position of the rocker arms, these should be for checking valve clearance. I'll take the cap off now to demonstrate its function for you. Taking out the small cap, it even has an O-ring. Usually, when measuring valve clearance, it can be a bit awkward. It's inconvenient, as you often have to bend the feeler gauge to insert it for measurement. Now look at this Santi's design. Through this small hole, the gauge slides in perfectly flat. This design is truly excellent. Very convenient for mechanics. Valve clearance is a critical value. If the clearance is too large, it creates a ticking noise. If it's too small, the engine loses power and speed. Mechanics will definitely love this design. Removing the entire radiator. This is its liquid cooling system. Here it is. The water pump is at the top right, and the thermostat is below. Since you've watched this far, please give the video a like. The Zonti's 150X also uses a pulse start system. That's why you haven't seen a starter motor yet. It utilizes the magneto I'm dismantling now, combined with these coils, to form a brushless motor. To start the engine, I wonder if Old Chow will utilize this brushless motor later to develop an electric assist feature. By adding 48 V of power, it could intervene during acceleration to boost performance, to increase overall power. Though 48 V lithium batteries aren't exactly cheap. This is the oil pump. The gear is made of nylon. Now I'm removing the oil pump. Next, I'll start dismantling the cylinder head. There's a lot more to see here. From here, you can see the head structure. It's a single camshaft, 4-valve setup. The timing chain is a 2x3 layout. Now removing the chain tensioner. It's a mechanical tensioner, not hydraulic. Honda models usually use hydraulic ones. The advantage of a hydraulic tensioner is that it extends the timing chain's lifespan. The downside is it's slightly noisier. That's why many people convert hydraulic ones to mechanical. Look at the exhaust rocker arm. It uses a DLC, diamond-like carbon, coating, because the exhaust side operates in harsh conditions. This approach is consistent with Zonti's 310 series. Reinforcing the exhaust rocker arm craft. The rollers on the rocker arms are from NTN. Let's check the camshaft bearings. They are TPI bearings from Taiwan. The manufacturing origin is Indonesia. Take a look at the 4 valves. For this cylinder head, Old Chow produces them in-house, including the cylinder block. It's a ceramic-plated cylinder. Let me shine a light to show you how bright the cross-hatching is. I'm sure everyone prefers ceramic cylinders. Old Chow really invested heavily here. Now, let me grab a screwdriver. I'll give it a scratch, to prove this is a genuine SATA screwdriver. Not some cheap brand. This is the advantage of ceramic cylinders. Extreme wear resistance. If this were a cast iron cylinder, it would have been scratched up long ago. Now look at the piston. He really didn't hold back, it's a forged piston. Made by Shandong Zhengtian. The piston is very light. Let's check the piston rings. The first ring uses East Asia's DLC process. Top tier quality. The second ring uses the PVC process. The oil ring also uses the DLC process. I must weigh this piston. It's engineered to be very light. Only 88.85 grams. I remember the Honda 150 cubic centimeters weighed in at 108 grams when I dismantled it. This one is much lighter. A lighter piston means less reciprocating inertia. All other parameters being equal, a lighter piston results in lower vibration. Of course, vibration depends on other factors too. The piston crown has a micro-arc oxidation treatment. For durability, the piston skirt is coated with graphite. You should have seen it just now. Check out the timing chain. It's a dead silent chain from Japan. Now we can split the crankcase. It seems Old Chow really likes aluminum. Even this small radiator bracket is made of aluminum. Alright, splitting the crankcase. It doesn't have a balance shaft, so you'll only see the crankshaft inside. Wow, no burrs on the crankcase. The surface finish is very clean. The crankshaft bearings are the same type as the Honda 150. No need for a detailed intro here. Let's check the bearing brand. It uses FAG bearings from Germany, specifically produced in India. Now you can see it clearly, right? It's the same design as the Honda PCX 160. The crankshaft is made by Jiangsu Gangyang. Since I have to reassemble this engine, I won't remove the bearing on the other side. It uses a TPI bearing. Opening the gearbox now. Let's check the bearings inside the gearbox. Cover off. Let's look at this one first. It uses a domestically made FAG. The one inside is from SKF. Actually, I see now it's a Nachi bearing. Note the TM prefix. This indicates special heat treatment, designed to increase service life. The other gears use Nachi as well. I won't drain the gear oil. You can see clearly enough. There are no metal shavings inside. Alright, the entire engine teardown is complete. Time for a quick summary. The materials are truly excellent. From the bearings to the ceramic cylinder, and the forged piston, then the DLC exhaust valve process, the Gates belt, the FCC drivetrain, and the DID timing chain. Even though the 150 cubic centimeters is a commuter model, when it comes to engine materials, Old Chow didn't lower the part standards. Just because it's a commuter bike. In the current industry, commuter bikes rarely get such high-quality materials. Kudos to Old Chow for this. Essentially, all the tech from the 368 engine and its high-end materials have been applied to this 150 cubic centimeters engine. This is really impressive. The quality is undeniable. People might say I'm being paid to say this. But look at the teardown. The materials are right there in front of you. These are objective facts. If you have doubts, You can buy one and dismantle it yourself for comparison. Now I have to put this engine back together. The bike still needs to be ridden. Thanks for watching, see you next time.